Hello, good morning, everyone. Welcome to this webinar called Unlock the Hidden Power of the Nature and Presentation of the Samples. And in this webinar, we will try to fulfill that discussion about how these properties, nature and presentation of the samples, shape your proficiency reliability. My name is Peris. I'm the General Manager of GSC.
I'm Alfredo Serrano, Head of Marketing and also consultant at GSC.
We will be with you during this webinar and we will send all this information.
Yeah, after the finish of this webinar, we will send you the presentation we are using today. Also, you will receive a poster that was awarded in the last Windsor PT Providers Congress that took place last year. That is about this topic. And you will receive also in a couple of days. We hope this record will be up in our social media. So please follow and subscribe in our social media in LinkedIn and YouTube.
Okay, so let's start, no, Alfredo?
Yeah, also, sorry, Anna.
Yes.
During the presentation, if you have any questions, you can send your questions through, and at the end of the presentation, we will leave a 15 minutes spot to answer all these questions.
Okay, yeah, good say. So to start, we're going to present you who we are. I think that most of you already know us. But just in case, GSC is a company that has been focused on the services for the laboratories in consulting, internal audit, training, and also proficiency testing, but reference material provider as well, which I think that we are already preparing. So we are a company of 30 years of experience. We all of our consultants and staff come from laboratories. We've been with the white coat, working as you are working in the laboratory. We know your problems, your issues. We've been in many proficiency tests involved, so we know the issues you have. And also because we, as internal audits and assessors for accreditation body, we follow and narrow collaboration with accreditation body and certification bodies. We have the broadest PT portfolio in Spain, for sure, and one of the widest in Europe also. And we, in our portfolio, let's say like that,
our scope,
we're working with the national reference laboratories and other international companies in proficiency testing issues. And at least, but the most important thing, I think, is that we have our ISO 17043 since 2010, which is the date where the standard was edited, was published. So we have a long period of time to get a lot of experience as recognized and accredited provider.
Yeah, and this is also important because sometimes it's mandatory that providers are accredited.
In Europe, we know that ILAC says that an IA that is preferably you should choose a proficiency testing provider that has been accredited under this standard. So let's go to the topic.
Okay, Anna, sorry. But you said that we are going to talk about nature samples.
Yes.
But why there's a monkey here and also in the first slide?
Be patient. You will understand at the end of the presentation.
Okay.
So when we are involved as a laboratory, we are involved in a proficiency testing program. We expect to make our comparison and the samples that we receive resemble very much to our usual samples. So they should be like very much our regular items, because this way, any problem we have, any satisfactory or a non-satisfactory result, give us conclusions about our performance.
So we can evaluate our performance in the proficiency test
for sure,
in base of the natural of the sample.
Yes.
Okay.
So the nature of the sample is very important, but sometimes although it's the most preferable presentation of the sample is to be natural, is not always available.
Yeah.
You know why?
Well, I guess it has something to do with transportation, preservation, or even levels.
Many of these topics you mentioned are the reasons why we sometimes have to renounce to use natural presentations or natural samples. The availability of the levels of interest, because we have to ensure homogeneity, stability, the transport issues that you have mentioned, and also to avoid all the manipulation issues that can be involved in the testing when laboratory receives the sample. So we need to have as laboratory, you need to have the confidence that if you have had a satisfactory result, is because you've done it well, and that if you get a non-satisfactory result, it's because you haven't done it well. So you have something to correct or something to
you have to take some actions.
Yes. So in this webinar, we're going to talk about the pros, the cons, the advantages, the disadvantages of the different kind of presentation for samples, and also the nature
of the samples.
And how this impacts in the reliability of the results of the laboratory. And this study we've made, and the discussion we're going to speak to you, is based on three very important points that I mentioned here. First, because as proficiency testing provider, GSC has a huge experience we've done for 13 years, so we have collected a lot of
data and information and experience.
Insights as well about what is important and what is not important in proficiency testing. But also laboratories, our participants have given us a very valuable feedback about what they care.
And you never forget about the other good way we get information is because we are consultants and auditors. So we have field experience with laboratories about how they get the results in the proficiency test and the main problems they find.
Yeah, the good practices, the not so good practices. And we know that the accreditation bodies demand to be very careful on this topic as well. So we have some experience and some different sources of information.
That's true. So when we comes to talk about the nature of the samples, we can make like two big groups for beginning. This is just an overview of the different topics we're going to talk this webinar. And when we talk about nature of samples, we can find two main groups, like naturally contaminated samples, or those where are spiked.
Yeah, spiked or synthetic, many degrees of manipulation of the samples that make this sample not completely natural.
Okay. And then when we talk about the preservation and presentation of the samples, we can make also two big groups, which are that we don't make any manipulations, just homogenization and preserving their natural character. Or we can make some process to try to get better conservations or better transportation stability.
Yeah.
That's it. And we will use techniques like lyophilization, freezing, or other kinds. We are going to discuss this in more detail.
So let's go deep to the nature of the sample. So according to the nature of the sample, we have different kinds.
Yeah, what kinds we can find, no?
Now we will start to understand about
the monkeys. Okay.
Natural sample is like a beautiful gorilla, no? From the wild. It's like what you get in the nature. This is what you want to get, not a gorilla, but a natural sample in your laboratory. So this is the most desirable sample you could
but I think there's some problems sometimes with natural samples because we maybe don't get to achieve the interest level on some analytes or some contaminants.
Yeah, that's true. So this is why sometimes we got incurred samples and spike samples.
I don't have very clear the difference between a spike and incure. Could you elaborate more about this?
Yeah, let's go back. The incure sample. The
Okay.
incure sample, you see, is like some kind of a monkey made with artificial intelligence. No,
Yeah.
you can see it. No,
it's almost human.
It's almost human, but it's not completely our beautiful gorilla.
Yeah.
The incure sample is a sample that has been spiked somehow, but after spiking, the analyte has followed all the natural process. It's like, for example, I make a cake.
Yeah.
Mixturing the flour and the gluten or
so
the allergen.
You add an allergen.
But afterwards, I bake it. I bake it off. I make the cake as I do it in the kitchen. So the product that goes out of this process resembles what is happening in a factory, you know?
Yeah, so as a laboratory, I will get the cake.
Yes, you will get the cake.
Okay, this is something similar that if you want to get an antibiotic sample to study proficiency test, then I get an animal and shot the vaccine or the antibiotics in the animal, and that, for example, collect the urine.
The urine or the muscle. So
yeah, but this is not the easiest way to get a sample.
Not certainly for an animal.
Yeah. So
I will get you to incure my gorilla.
Yeah.
So the most used way to add the analyte to the sample to get the levels we need is to spike it, to add it. No? And
there's any problems with this kind of spike samples that we have?
We have some problems in the sense that the relation, the link, the unit, the unification,
the
interaction of the matrix and the analyte not always resembles what happened in reality. But we'll go further, okay? But a spike sample, and to have some fun, we can have a very spike sample, you know.
So we are not talking just high levels, no? Here?
No.
Okay.
It's just a joke, no? Is that at least samples, lucky for our health, normally are not contaminated with microorganisms or with heavy metals or with pesticides. So we need to spike it together.
Yeah.
Okay? And also we have just in the edge of everything a synthetic artificial sample that we can make.
I can wrap my head around this concept of synthetic samples. What do you mean when you talk about this?
I will give you an example.
Okay.
If we want to get a wastewater sample,
yeah,
sometimes we could go from the distillated water, adding the salts, the contaminants, the lead, whatever the analytes we are interested in. But also, we try to pretend the behavior of a wastewater, adding milk powder and some other things that normally would go into the normal wastewater.
So you compose the sample from the scratch?
Yes. So piece by piece and make something that no way comes from the nature.
Okay.
So the way the aspect of this monkey is not exactly that the one before, no?
Yeah.
The first one.
Well, then, and we can talk, as we said in the previous slide, about this first group of nature samples that will be the natural samples, which are good because will be the same that we usually analyze in our laboratory.
Yeah, normally natural samples or naturally contaminated samples.
Yeah, that's the way we find in nature.
In the nature are very processed. Mainly we mix it up, we homogenize, so we are sure that all labs will get the same bottle.
We say yes.
But this is the sample that the best represents the quality of our results. As a lab, if I get a good result in a natural sample,
it's the most desirable one.
It's the most desirable the most accurate, no, to the real samples.
And that's it. Also, it will suppose to the laboratory that they won't go out of their routinary way. They will make the process as usual.
As usual. So they don't need to manipulate previously, so no risk of contamination. Different at what they do with the regular samples would happen.
And also, a good thing that natural samples has is that we cannot manipulate the results of the PT.
Yeah, it's impossible. So we know that when we have got an incorrect result, this incorrect result doesn't come from manipulation mistake.
So
the preparation.
So we must focus in our investigation in the analytical process.
Yeah. So
when we talk about the pros and cons of natural sample, then if we make a resume about this, we can say that the good things are the natural sample are similar to our ordinary samples that we manage in our laboratory, that will need low pre-analysis handling, the regular that we already has established. And we are sure that the proficiency test result won't be affected because there's any possibility of falsification of the results we get. Also, this kind of presentation reduces the possibility for any manipulation mistakes. Because we are used to manipulate already the samples this way. So it's nothing different from what we do day to day. And also, we can expect that the behavior of the samples will be a good resemblance of the natural samples that we also receive every day. So, and when it comes to preservation and transportation and deliveries, we don't need nothing special further than we already need for the samples we receive.
Yeah.
So there's plenty of pros.
Yes.
In our scale.
There is only a con, no?
What is this?
And we have talked about it before, is that we don't find natural samples always with the right levels.
So this is maybe talking more about this kind of like contaminants or microbiological parameters, but when it comes to other parameters, we'll be fine.
Yes. In this case, we need to spike samples because the regulations brings the highest level permitted in a sample, and we need to prepare samples sometimes close to these limits, which is not what will happen in the nature always. So this is why we need
sometimes
manipulated samples, spiked, cured, synthetics, what we have been talking already.
So it's not the preferred option, but sometimes is the most suitable.
Is the only option. Yes, that's right. So what is the only problem we have with the spiked samples is that the interaction that we mentioned before between the matrix and the analyte, this interaction is not always as it happened in the nature.
You will say it is more weak.
It's more weak, or there is no link at all.
Okay,
Can you give me an example of that?
Yeah, I guess then we will have higher recoveries when we analyze them. Yeah, I'm thinking about, for example, in a matrix like here, when you try to study clenbuterol, for example, you can say the difference when you are studying a natural hair that suffer the process of metabolic incorporate the clenbuterol because between a sample that is just a spike.
Yes, during the analytical process in a natural sample, you need to break this interaction analyte and matrix. When the sample is spiked, even if the process of breaking this bound doesn't work, you don't notice it because the analyte is already free over covering the sample. So it's not perfect, but sometimes it's the only option.
It's the only option.
although you want to incur the cow with clenbuterol.
And also that doesn't assure that the sample will be homogeneous.
Yes, that's right. So, which are then the pros of a spike sample?
When we talk about the pros in spike samples, we can say that they will be also similar to natural samples because we just get the matrix and then add the analyte. So the behavior of the sample will be similar. Again, the laboratory won't need to do any extra operations. So we will have low pre-analysis handling risk. And also, since the laboratory doesn't manipulate the sample, there's no risk of falsification of the results. Also, because we follow our ordinary process, the chance to get some mistakes or cross-contamination during the manipulation of the muestra of the sample won't be very likely. And as we talk in natural samples, again, when it comes to preservation and delivery, there will be no special needs other than the regulars.
Yeah, right. But remember, Alfredo, that there are two main problems. On one hand is that because of this link or interaction problems, the behavior of through our analysis of the sample may not be the same, no? Because we can get this over recovery risks. It's not always like that. Sometimes the spike, speaking a sample, the analyte reproduce perfectly what happened in the nature. For example, cation or an anion in the water, in natural water, the anion or the cation are solved in the water and there is no interaction.
Yeah, so this problem depends mainly in the nature of the sample, of the matrix and the analyte. Yes. So it's something that not always happen, but could happen.
Yes, but what is for sure is that if it happens, if the recovery of these samples is higher for all the laboratories, the assigned value would be higher compared to real samples.
So in a way, the average will be biased.
Will be biased compared to a natural sample. Okay. Every laboratory will work with the same conditions.
So that's the thing. It won't be a problem because everybody's in the same conditions.
Yes. Right. So let's go further. Let's go to the preservation, to the presentation of the samples. Okay, which is a big and a huge issue, and this is something that concerns very much to the proficiency testing providers, but also to the laboratories. So what we are very used to find this kind of sample.
Okay. What kinds we can find?
Lyophilized.
I'm not very familiar with this concept. What is lyophilized samples?
Do you see my monkey is dry, frozen, as comparing to the nature? So
those are ice cubes.
Yes, it's ice cubes. So something like that. No?
Okay.
So a lyophilized sample is a natural sample. Sometimes it's just the standards or the stains that have been dry, completely dry, and frozen.
Okay. But this kind of treatment is suitable for every sample?
Not always, but when it is, what happens is that you got, for example, a piece of meat like this big, no? And after this process, you got like some little grains of powder.
Then when you process the sample in the laboratory, you will have to change your methods or...
The preparation of the sample is quite different, could be quite different. For example, the first thing you see is that you need to weight a different amount that it would be a real piece of meat.
Yeah, because you are weighting dry. Yeah, you are weighting dry substance.
So weight issues, weight mistakes could happen.
Okay.
But the first thing, well, one of the things you do almost immediately in the laboratory is that the lyophilized sample must be hydrated.
So our monkey needs to drink.
Yes, our monkey needs to drink. So that means that you need to add amount of water of solvent.
But I can mistake and not follow the instructions and add a different quantity of water that is required.
Yes.
So
Another
this will be an issue, could be an issue.
Yeah, another way of mistakes and also of wrong preparation.
Okay.
In microbiology, Alfredo, also
Yeah.
something happened is that in a dry frozen sample, lyophilized sample, the microorganisms used to be a little bit sleepy. So we need to wake them up, no?
Yeah, but the thing is, we send this like this way, no, sleepy, because we don't want the strain to evolve during the transportation and before the laboratory start their process of analysis.
All this is a question of getting more stable samples. But when you receive the sample in the laboratory, you need to follow very well the instructions to hydrate it and to wake up the microorganisms so they will react to the rest of the process as a regular sample.
Okay.
Yeah.
And do you think those two are the most used ways to preserve the samples?
It's very safe for the provider, but it's very risky for the laboratory. But then still there is one more way. Well, there are more ways to preserve.
We're talking more.
The one I want to show you is this one, and I want you to figure out which one is this.
Maybe frozen samples?
Maybe. Yeah, this is the way we use to preserve the samples that need preservation.
Yeah.
Because freezing in certain conditions and controlling temperature and time in delivery is a way that is the only way that we find that laboratories, when they receive the sample, they really receive the sample as if it was natural. You know, the only thing that they need to do is to defreeze. To defreeze the sample, to get the frozen sample. And I think that laboratories are very used to defreeze samples. No?
So would you say this is the most common, the most used technique for preservation?
For us. No, okay. I think that we are the very unique provider in Europe that makes this kind of preservation.
So this is a differentiation point.
This is a very different point. Yeah. But you see that in this case, the only things that laboratories have to defreeze in conditions that are very known by everybody.
So no special manipulation needed.
It's like if they receive a frozen lasagna in the laboratory.
Yeah, or seafood.
Or seafood to measure, to analyze listeria or something like that. The first thing they have to do is to defreeze. So they need to guarantee that the sample conserves all the properties. So they defreeze it slowly, etc. There's
in a controlled way.
Many standards that says how to do that.
Okay.
It's part of the process. What is that?
I don't know. I just see a mother and a child, a monkey child and a mother. Maybe we are talking about the split samples?
Yes. You're right, Alfredo. The split samples is the presentation where when the sample is sent, like the natural sample in one bottle, and the stains or standards, the concentrate that has to be added in a different container.
Okay, so I will get two different bottles, and then I need to mix them up.
Yes, and then there is a problem more that you need to add to the laboratory, because in this case, is the laboratory who's speaking the sample.
So you say that they may cheat?
They may cheat, or they could make mistakes when mixing up.
Because our clients doesn't cheat, eh?
No, our clients don't cheat at all. And so, resuming all this, this summary, we have the sample what we call type C, which are samples that respect the usual presentation, frozen or not. So
like the lasagna, no? Like we can get a lasagna or we can get an apple.
Yes, okay. And and is a way that laboratories usually receive. What we know for sure is that laboratories never receive as a regular sample
A split or a lyophilized.
A split or a lyophilized. So this is something that goes far away from the routine of the laboratory items. And now the sample, what we call sample D, is the sample that has been homogenized, that has been enriched or not, spiked or not.
And then suffers one of these process of preservation that we just discussed.
Yeah. And why do you need that we need this kind of preservation?
Well, I guess if the matrix is not stable, maybe the analysis is not stable, or the combination of both is not stable.
Can you give me an example of a non-stable matrix?
Not really now.
Meat, for example.
Meat, yeah, for example.
Any
or
food,
fish, yeah.
Any food that you send must be preserved during the delivery.
So we need to
preserve it
somehow.
Maybe if I spike or I look for lead or cadmium or mercury.
Yeah, maybe the analyte is stable, but not the
matrix. But on the other hand, it could happen that the analyte is not stable.
For example, volatiles.
A volatile in water
could be an example of something that the analyte is not stable.
But the matrix?
Well, the matrix is stable.
And sometimes there is a disaster.
Neither of them.
Both of them, matrix and analyte, are unstable. So we have categorized in 3 kinds of preservations, mainly preservation, special preservations that we could get as laboratory from a proficiency testing provider. One, we've talked about all of them, matrix and analytes that have to be added in the laboratory are in different containers.
The split ones.
They homogenized and preserved by lyophilization. The analytes could be spiked or not.
Okay.
Even sometimes the lyophilized is split from the
also.
And when we homogenize the sample and preserve just as some real samples, freezing the sample, so you receive a frozen.
So if we need to compare these techniques, what we can say, what are the best techniques to preserve the samples? Well, if we look at frozen samples, the one we usually make, we can say that they need few manipulation, and so then will be less possibility for mistakes or contamination. The pre-analysis handle will be as easy as just defrost the sample and then add as a regular sample. And for sure, this kind of sample, since the laboratory won't have any split, any concentrate or nothing related, won't suppose a risk of falsification of the results.
Yeah.
But in the other hand, well, special needs for delivery and special needs of preservation, we need to control that these conditions are guaranteed during all the process from the delivery from the provider to the laboratory and then when arrived to the laboratory.
Yeah. And it's for sure that in a frozen sample, the laboratory has not a long time to start the test. So there is a window, what you call the window, a short time, 24, 48 hours, where they need to start the analysis. No? But since the delivery is very well planned, the laboratory can occupy themselves.
Can manage all the...
But in a lyophilized and concentrated samples, you can see a lot of red points.
Yeah, I don't see this is a good thing, the lyophilized.
Well, we've been talking very deeply on it, but we want to make a summary of all the disadvantages, no? So the lyophilized and concentrated is not very similar to our ordinary samples. No laboratory receives this kind of samples in a regular basis. So because they have to mix up, because they have to defreeze, to revival the microorganisms, and so they have a high risk of manipulation mistakes and of contamination as well.
So it's very important to follow the instructions.
It's very important. And unfortunately, some laboratories don't follow on purpose the instructions.
Are we talking, for example, of Legionella?
For example, no, if you receive a stain to be added to the water, no, I don't know if you are a laboratory, if you can avoid to try to measure what is in this bulk, no, what is in this vial, because it's easier, it's much easier to make
the result, no? To get the
to
result.
know the result of this, that to mix with the water, to filtrate, concentrate, and evaluate, which is a very large procedure and a lot of, with a very low recovery. No?
Yeah, I see sometimes when I audit in labs that from time to time, when you go and check the results of Legionella analysis, for example, we know that there are around 30 to 40% recovery rates in Legionella, but then, but then sometimes when a proficiency test that has arrived in this form, we can find 80, 70% rates of recovery, which is not really common.
No, not very common. No, and this brings you to the next problem, is that if a lot of labs do that, if a lot of labs manipulate in a wrong way, but in purpose this, they got higher results, different results, but if they are a lot, the mean value, the assigned value is going to be false. So the laboratory that has done the process properly in a honest way is could be disappointed.
Yeah, and everybody will get affected by this.
Yes.
So it's not fair for the other participants.
Yes, yes. So we need to diminish as much as we can as provider, and this is something that the standard, our standard also says. We need to make all the barriers that we can to avoid this kind of
reduce the chances to this to happen.
Yes. And well, in the other hand, it's real that lyophilized samples need not critical conditions for storage or delivery, at least in time.
Okay.
Yeah,
that's the good thing.
It has in temperature, but not in time. It's more flexible for laboratory, and it's more flexible for the transportation in time. But in case of concentrated, in this kind of split samples, the needs for preservation can be very, very important as well, because as the standards, sometimes they don't have to have a battle of the standard running around the world for 3 weeks, no? So time and temperatures also require special parameters.
So these are the most common techniques, but are the only ones to preserve the samples?
No. We have some others, no? We are focused in that because the rest is something that we in the real samples we do it as well in the laboratory, which are other techniques of preservation. The techniques of preservation is like the chemical addition. This is something that we use very much in laboratories, because from sampling to laboratory, sometimes we need to stabilize the analyte.
Yeah, for example, when we add some acid in the sample to preserve metals or heavy metals and volatiles.
Yes, this is a good example. This is something very used in environmental samples. But the good point is that there are several sampling guides, ISO, the standard methods for an analysis of wastewater that gives you a prescription of how to make this chemical addition.
And when we use this kind of preservation, we should declare as providers?
As providers, we should give all the information about how much, what and how much we have added to the sample as a stabilizer.
So the laboratory knows what kind of sample they are dealing with.
Yes.
Okay.
This is important, mainly in chemical tests for preparing their own standards for calibration.
But this is, for example, this technique is very used in the environmental samples, but maybe not that used in food samples, no?
No, we don't find it so often, but still there are some examples. I wrote down this one, which is acidiol, a chemical preserver in raw milk. It acts bacteriostatic.
So you will be able to study both the physico-chemical and the microbiological parameters.
Yes, this is a chemical stabilization. And but there is always a problem, no? In some cases, the standard, the preservant we add, the chemical, can interfere in the analytical method we use. So there are some restrictions in the method.
So there are some handicaps also with this kind of conservations.
So infrared methods in some cases cannot be used depending on the preservant we use.
Okay.
You see my monkey?
Yeah.
Chemically
so
preserved.
Cute. So cute.
Yeah. Well, but we also use something which is a little bit strange to explain. I'll try to explain.
Okay.
Is that when we need to make the test runs properly, we need to make an addition of some kind of stain or microbiological stain. Very often the sample itself has this contamination.
Okay.
But as this contamination is present, the sample evolves very fast.
So we need to split.
The real sample that we sterilize to make it stable, and then we bring the stain separately to be added. So it's like the beginning of the test.
But in this case, we cannot manipulate the sample because the parameter is already in the matrix, and you just start the process for the laboratory to measure.
Adding this microbiological stain.
So it's, in a sense, it's different from the other cases we already discussed.
I will give you an example.
Okay.
Laboratories in environmental fields used to measure what we call BOD, biological oxygen demand. This is a method that what measure is the consumption of oxygen in the sample.
Yeah.
And the consumption due to the organic matter that has the sample and produced by bacteria that have the sample. So if the natural sample is sterilized, it's just natural, all the organic matter is in the sample, but we send separately the flora that might be added to the sample.
Okay.
We use it only in these cases.
So we are going to jump to some conclusions.
Yes.
Then.
You start, Alfredo.
Well, when we are talking about naturally contaminated samples, then we can say that it ensures that the laboratory gets reliable results on the consensus value when participating in the proficiency test. Also, that the behavior of the sample will be as expected, so no difference in the analytical methods, but the bad thing or the con of this kind of samples will be that we not always achieve the desirable levels, for example, when we want to test thresholds or legal limits.
Yes, right. If we talk about spike samples, that this is the solution to get the levels we need. There is also another advantage we didn't mention before, is that in a spike sample over a natural sample that has not the analyte we are investigating, it's possible to know the reference method, value, because we know the amount we have added, and if we do it in a certain
way,
no, with calibrated equipment, etc. and from reference materials as well. But we know, and we've talked about it.
The handicap is
the interaction. Not always. There we got the interaction matrix compound that it should be desirable.
and that will follow to over recoveries.
This is what happened over recovery. So at least the consensus value would be higher than the one we would get if the sample was naturally contaminated. And in addition, when the spiking of the sample is made in the laboratory, which is what happened with the split samples or the lyophilized samples when it's split from the matrix, then there is a risk of manipulation, there is a risk of cheating, as we talked before. No? So there are not always advantages in all their presentations. Okay.
Well, and then just to resume now about the preservation techniques, why we use them. First, because it allows us as providers of proficiency tests to achieve a greater stability of the samples, so we can deliver everything to more distant locations. And for example, in our case, we need to deliver all around Europe. So we need that the samples are stable. And also allow that we have long periods of storage in pre-analysis, also for us and also for the laboratories. But in some cases, depending on the presentation of the sample, could lead to improper handling by participation, and then also happen what Anna just discussed about the cheating or wrong wrong manipulation of the samples. So
yes.
Those are the things that could happen. But Anna, then after all this, when we are talking about what we are doing here in PTGCC, when we work with the proficiency tests, what are our way?
I think I'm not going to give you a surprise.
No?
No. What we do is, first of all,
natural samples.
We go to our gorilla. When we are in love for our gorilla, we go to natural samples anytime we can.
Okay. So always that is possible, we will use natural samples. And then when we want to check those threshold or legal limits, what we do? We use natural samples, but we spike it. But it remains that we use natural samples. Yes. Always. And the speaking is made in our laboratory, in our facilities. So the laboratories, our customers, receive the samples that to be measured, to be analyzed. So no need of pre-handling. Yeah, they have no pre-handling. But sometimes, in very few times, we need to split up the sample. Okay. I think that we have now market like 200 different proficiency tests. And how about how many do you think we use this technique? That 1 or 2. So less than 1%, 2%. Yeah. Only in some few cases in environmental samples. Okay. And finally, the most used technique will be for us is the frozen sample. To freeze the sample is very used for us when it's needed to be preserved, and that means that we need to control the time to have the best agency for delivery, etc. Control time and temperature, so laboratories get the right sample at the right time in the right conditions. Okay, so it's very demanding for us. But I think that this is the way that it should be done. So the laboratories have the confidence that when they got a wrong result, it's not because they have done a wrong manipulation of the sample, a wrong preparation. This is like very discussing, no? Yeah. So our philosophy is natural samples and low manipulation in the proficiency test. So you can get the results as real as possible. Yes. So the few as we can manipulation. So then
Or monkeys. Do you understand now why the monkeys?
Yeah, I do
Everybody
understand.
does understand why the monkeys
Yeah.
were in the
And
first place.
it was a good metaphor. So it's now time to get some questions that we get during the presentation. One of our colleagues are giving us a couple of them. Yes, I have one question. We will answer this now, but if you have any other questions and want to make us these questions, please
write it in the chat, but you feel free to write by email directly to us or through your distributor, because your distributor will give us the questions.
And we will get to you shortly.
Yes.
One of the persons in the public asked if what is the process they should follow when the sample gets to the laboratory, is delivered defroze or partially defroze.
Okay, because of the time term, the period we assure that laboratory gets the sample. Actually, they should get always the samples that have been preserved or frozen or partially frozen. If a sample is partially frozen, means that during the delivery, during the transportation, the temperature conditions are under the margins with the thresholds we know, and the right limits. If the laboratory receives the samples completely defrozen, they should call us through our distributor or directly to us, and we will bring back another bottle, another sample without any problem. But sometimes it's very difficult for the laboratories to know if the sample has arrived frozen or not. I'm talking about, for example, a powder or a cookies.
It's difficult to notice if it's the frozen or not.
So in these cases, we add to the complete parcel a bottle with a liquid, water or something like that, to check when it arrives to the laboratory if there is still some ice into this bottle.
So you have like kind of a witness of the good transportation practices during the delivery.
All this is written in instructions, so laboratories need just to read these instructions to know how to proceed in the future.
Okay, well, we don't have any more questions at the time, but maybe some people will make it arrive to us.
Yes.
So if we get another questions, we will answer as with.
We always answer all the questions. So Alfredo, we just want to thank you very much for joining us in this webinar. This is the second one we've done for you, especially for you. But if you have any other topics you want to talk about, it's perfect. We will take into account and we will prepare something for you. And we hope to see you again in the next webinars that will be in this
during this trimester or the next. And please, before leaving, complete the survey we left.
Yes,
it will be very useful for us. So please complete the survey.
So don't forget that we will answer all the questions that you write now or further on, okay? And we are for you to help you. Thank you very much and see you next time.
See you next time.
Bye-bye.